Hi, and welcome to this video on lesson 5.4, day 1, sum and difference identities. So before we get into sum and difference identities, as usual, I like to do first on a problem that we've been doing recently, which is, of course, solving trigonometric equations. So let's get into it. So here we're asked to find all the solutions to the trigonometric equation. 2 is equal to 4 cosine squared plus 1. So how do we do this? Well, first of all, I'm going to go ahead and write this over here, so we have a little bit more space to work with it. So I'm just going to rewrite the problem. Sorry, I didn't mean to cough in your ear like that. Okay, so first step, what do we want to do? Well, again, the first step, the big meme, right? The big thing we always want to remember when dealing with trigonometric equations is to isolate the trigonometric expression, which of course in this case is cosine that has a square. So to do that, the first thing we're going to do is subtract 1 from both sides. Cancel, and 2 minus 1 is of course 1. That's going to give us 4 cosine squared theta. Then we are going to want to divide by 4 on both sides. Cancel, cancel. So we end up getting that 1/4 is equal to cosine squared of theta. And what do we do at this point? Well, again, you should remember that anytime we have a square, anytime we have something that's squared that we want to get rid of the square, we need to take the inverse operation of a square, which is, of course, the square root. So we want to take the square root of both sides, and that's going to give us just cosine theta. And remember, whenever I square root a fraction, I'm actually going to square root both the top and the bottom of that fraction. So the square root of 1 is just 1. And the square root of 4 is, of course, 2. And, of course, because you're square rooting a square, you're going to put a plus minus in front of the 1/2. Okay, so what do we do at this point? Well, again, what we have to say is we're looking for theta. So what we have to say is what theta, or what angles on the unit circle, would make cosine into plus or minus 1/2. So this actually, we want both cases where cosine is positive 1/2 and negative 1/2. So we actually have a unit circle conveniently on this paper down here that we're going to need for today's lesson. And where do we see cosine, or the x-coordinate, and 1/2? Well, the first one obviously is going to be at pi over 3. So that's going to be our first angle, or theta, that gives us a cosine of 1/2. So we go back down here. Okay, so we keep looking. Well, again, we have a negative 1/2, and normally if the answer was just 1/2, we wouldn't want to pick 2 pi over 3, but because we want both where it's positive and negative 1/2, we will put 2 pi over 3. And at this point, you should notice the pattern that we're probably going to get 3's in every radian that we choose here. So again, let's look at 4 pi over 3 down here, and sure enough, there is a negative 1/2 in the x. So we're going to say 4 pi over 3. And then next, we go to another pi over 3, and sure enough, that also has. So we're going to say 5 pi over 3. Okay, so normally we'd be done, right? But again, remember this says find all of the solutions, right? So that's saying that we not only want the solutions from going once around the unit circle, or 2 pi around the unit circle, we want them for also going as many times around the unit circle as we want. We didn't discuss that, so we're going to kind of make it really simple here. And so what we're going to say is, okay, if I go all the way around the circle, that's going to be 2 pi. And I know that if I go an additional pi over 3 past that, that's going to give me a 1/2 in the x again. So what I want to do here is say, okay, well, 2 pi plus pi over 3, well, that would be 2 pi is the same as 6 pi over 3, and then I add a pi over 3. That's going to be 7 pi over 3. And then we can kind of just draw these ellipses, these 3 dots like this, just to indicate that that pattern will continue, that we're going to keep getting the radians that have a over 3 with them, and those will be the answer to this equation. So this actually has an infinite amount of answers. We have anything that has a radian pi over 3, 2 pi over 3, 4 pi over 3 will continue on forever to be solutions to this trigonometric equation. Okay, so let's talk about something called sum and difference identities. I don't know how we're angle identities. It's actually sum and difference identities, but anyway. So here are what we call our sum and angle identities for cosine, sine, and tangent. So basically what this says is that if I have two things or two numbers or two variables added inside of cosine, so cosine with an alpha plus beta inside of them, that actually is going to be the same as having cosine of the first thing, cosine of the second thing, minus sine of the first thing, times sine of the second thing. And we notice all of these have patterns, and the pattern differs based on whether you it's sine or cosine, and also if it's positive or negative. Now, one thing to keep in mind is try to always notice patterns whenever you're looking at new formulas, right? So here I notice that I have cosine of theta is cosine minus sine. And here for the cosine with a negative in between, it's cosine plus sine. So notice for cosine, there's two cosines and then a sine, and then the signs actually differ from what you put on the right. So if it's plus, you put a minus. If it's minus, you put a plus. For sine, though, it's going to be sine, cosine, sine. So, and then that typically will have the same sign as whatever was inside. So negative, negative, there. For tangent, we just wanted to show you that there are sum and difference identities for tangent, but we're not really going to concern ourselves with these. Just want to kind of make you aware that they actually exist. So why do we want to learn these? Why are they useful? Well, the reason is because two main reasons. The first is that we can use these to find, evaluate trigonometric functions at angles and degrees that aren't necessarily the special right values, so 30, 45, or 60 degrees. The second reason is that these actually help us to verify identities, and in the case of, say, we're adding two things inside of an identity, it can especially help out in those particular cases. So let's dive in and let's just do a few problems and see what in the world I'm talking about. So first things first, let's go ahead and look at sine of 15 degrees. Okay, so sine of 15 degrees, what I'm going to do here is think, okay, I look on my unit circle and I say, let's see, is there a 15, and we see that there is no 15 degree on the unit circle here. So we kind of run into a problem because I don't know what coordinate that would be. So, but what I can do and what I can recognize is say, well, what if I make 15 the sum or difference of two of the angles that we do have? So for instance, if I think about it, 15, I can take 45 and subtract 30, and that would be 15. So what I can do here is, instead of saying sine of 15, I'm going to rewrite this problem as sine of not 15, but instead I'm just going to make it 45 minus 30 degrees inside. Now, why in the world would I do that? Well, because now we can use our sum and difference identities to break this up into separate sine and cosines that actually will be values on the unit circle. So let's go up here and see. So looks like, let's see, we have sine a number minus a number, so that looks like it's going to be in the difference identities category, so this one here. So let's use it. So we know that if this is the case, we're going to get, well, we're going to say sine of 45 degrees, which is the first number, cosine of the second number, 30, minus cosine of 45 degrees times the sine of 30 degrees. So there we go. So now we've broken it down with everything only having one trigonometric value, right? And we actually can then use the unit circle because we do know what sine of 45 or cosine of 30 is, right? We can just look on our unit circle. Okay, so sine of 45 degrees, well, I look at the y-coordinate at 45 degrees, and that looks like that is the square root of 2 over 2. So sine of 45, we say, is the square root of 2 over 2. Cosine at 30, well, that looks like that's the square root of 3 over 2 here. So I'm going to make that the square root of 3 over 2. Minus cosine of 45, the x-coordinate there is the square root of 2 over 2 again. And sine of 30, again, the y-coordinate, that's 1/2. Okay, so what happens now? Well, let's just do some math. It's just algebra to kind of put all this stuff together. So what we're going to do is we're going to multiply these two together. Now remember, when you're multiplying fractions, you want to multiply across the top, across the bottom. So what we're going to say here is, in this first term, we get a 4 in the bottom, and we get a square root of 2 times the square root of 3. Square root of 2 times 1, of course, is just the square root of 2, and 2 times 2 is 4. Now the nice part about this is that notice we have that common denominator, and whenever we have a common denominator, we can just write one fraction bar with our common denominator in the bottom, and then we can just do the arithmetic in the top. So the square root of 2 times the square root of 3, what do we do there? Well, whenever you have two things inside of square roots like this, you can actually multiply those together to bring them together. So the square root of 2 times the square root of 3, 3 times 2 is 6. So we'll just write that as the square root of 6. And of course, we'll subtract that from just the square root of 2. And that is going to be our answer. So notice the power that these sum and difference identities have allowed us to do. They've allowed us to easily express what the sine of 15 is in radical form, right? We don't just have to do this ambiguous thing in our calculator where it just spits out a number and, we just write it down. We actually have an exact radical form of what the sine of 15 is, having used our sum and difference identities here. All right, let's keep going. Let's do another one together. So this time we'll do the cosine of 15 degrees. So this time we're going to do the same thing but with cosine of 15 degrees. Now we already know cosine. That's going to be, let's see, that's going to be cosine is just, we can change that to 45 minus 30 like we did up here. And here, now we have to use the cosine difference identity, though. So that tells us that cosine, cosine plus sine, sine. So we're going to say cosine of 45 times cosine of 30. And remember, with cosine, the sign's going to differ in the middle. So that's going to actually be a plus in the middle. And it's going to be sine 45, sine 30. Sine 30. Excuse me. Okay, so then at this point, we go to our unit circle and we see if we have any values that match those. So cosine of 45, that looks like that's just the square root of 2 over 2. Cosine of 30, that looks like that is just the square root of 3 over 2. Sine of 45, that is the square root of 2 over 2. And sine of 30, that looks like that's going to be 1/2. Just want to be extra careful that I'm doing this right. Yeah, make sure, kind of check our answers, make sure everything looks good, and looks like it does. All right, so let's go ahead and work this out. So again, we can skip some steps here if you'd like. You'll again notice that in the bottom we're going to get a common denominator of 4, so maybe I can write that without having to go through this step right here. Square root of 3 times the square root of 2, that's just the square root of 6. And the square root of 2 times 1 is square root of 2. So we get that result right there. I'll go ahead and box that answer in. Okay, cool. So those two problems worked out. So what I'd like you to do now is go ahead and do sine of 75 degrees. Pause the video, think about it for a few minutes, see if you can't get either with a sum or difference of 30, 45, or 60 to add up or subtract to 75 degrees. And see if you can figure it out, and we'll come back and talk about it. So go ahead and give it a shot. Alright, so now I'm assuming that you've kind of gone through, paused the video, and worked through this problem. So let's work through it together. So sine of 75 degrees. So again, I want to find two special 2 degrees on the unit circle that add up to that 75. So let's think, let's see, 60 plus 45 is going to add to 105, so that's not what we want. 30 plus 60, that's 90, no. 30 plus 45 actually is 75. So let's go ahead and do that. So we're going to say sine of, split it up into 45 plus 30, which does add to 75. Okay, so now we use our special our special sum identities, and because we have a sign with a plus in the middle, again, it's going to do sine, cosine, cosine, sine. So we're going to say sine of 45 degrees times cosine of 30 degrees plus cosine of 45 degrees times sine of 30 degrees. And then, of course, we just look on our unit circle. Sine of 45 degrees, well, that's the square root of 2 over 2. Cosine of 30, that's going to be the square root of 3 over 2. Cosine of 45, again, also the square root of 2 over 2. Sine of 30, that, of course, will be 1/2. And, of course, we do what we did up there, which is, let's go ahead. It looks like we're going to get that common denominator, again, of 4. Where square root of 2 times the square root of 3 times the square root of 6 plus the square root of 2, and we are done. So again, that's what you want to always do. Try to figure out two numbers that break down into 45 and 30, and then, into the number inside of the sign, and then that's going to allow you to use the sum and difference identity to break it down into your special right angles on the unit circle, and then you can go forth and solve the problem. Okay, so now that we've done it with degrees, let's try it with radians, because radians is a bit more challenging, and we'll see how it is. So we have sine of 5 pi over 12. So we want to basically do the same thing we did with radians, which is break this down into two things that add to 5 pi over 12. But that's a little bit more of a challenge because we don't know exactly, we can't just take two numbers and split them up. We have a fraction with a 12. So we have to do a little bit of thinking here to get it. Not too much, not too bad, but we'll see. So let's see, why don't we, 5 pi over 12, well that's a little less than 1/2, right? 5 over 12 is less than 1/2, so it's probably going to be in this range over here. So why don't we do this? Let's maybe try out a few. Let's maybe try, I don't know, 2 pi over 3. I'm going to do some scratch work up here. Divided by 3. And what if we try to subtract pi over 4 from it? Okay. So what's going to happen there? Well, again, to subtract these, we're going to need a common denominator. And to get a common denominator here, we'll go ahead and, let's see, the bottom probably is going to be 12, because the common multiple of 3 and 4 is 12. And let's see, okay, 4 times 3 gives us 12, but 4 times 3 is going to give us 12 there, but again I have to multiply the top by 4, so that's going to be 8 pi. 3 times 4 is going to give us 12, so that's going to give us 3 pi in the top. And again, all we have to do is the denominator stays the same whenever we subtract or add fractions, but 8 pi minus 3 pi is 5 pi. Okay, so now that we've realized that 5 pi over 12 is just these two combined here, we can break it down into those two. Now, what I would recommend is that you know that these two are going to subtract to 5 pi over 12, but I would just put them in as their old selves, right? Don't put it as 8 pi over 12 and 3 pi over 12, because that's not what is on the unit circle. These two are. So instead of saying this, we're going to say, okay, well, I put 2 pi over 3 minus pi over 4, and we know that that is going to give us 5 pi over 12 if we do all the fraction-y stuff. Okay, so now, again, we use our sum and difference identity to break this down. So this one looks like it's a sine difference. So remember that's going to be sine cosine minus cosine sine. So it's going to be sine of 2 pi over 3 times cosine of pi over 4 minus cosine of 2 pi over 3 times sine of pi over 4. So those two like that. Okay, so again we do the same thing. We see what cosine and sine is at those angles, or I guess, you know, the radians in this case. I'll write it over here. Let's see, so sine of 2 pi over 3, well the sine of 2 pi over 3 is the square root of 3 over 2. The cosine of pi over 4, that's going to be square root of 2 over 2. minus cosine of 2 pi over 3, that's negative 1/2, and sine of pi over 4, that is the square root of 2 over 2. Cool. All right, and then we just do what we did last time, except we're going to have to remember one thing here because we do have a negative. So again, we have a common denominator for 2 times 2, 2 times 2. Let's see, in the top we have square root of 3 times the square root of 2, that is again the square root of 6. Now, we have 1 times the square root of 2, but there's a negative here and there's a minus sign. So those two are actually going to cancel and become positive with just the square root of 2 behind them. And then looks like that's as simplified as we can get. So that's going to be our answer. So again, notice it's pretty much the same deal. The only difference is at the top here we have to think about it a little bit harder because we have to break it down with fractions, and it's not as simple as degrees. But again, just a little bit of logical thinking can kind of go a long way there. So what I'd like you to now do is go ahead and try number 5, using sort of the same method here. It's pretty much the same thing, except I'll give you a little hint. You're going to stay in the first quadrant, the two values that you're going to actually add together. So I'll give you that hint too. You're going to add 2 of these together, and that should give you 7 pi over 12. So go ahead and give that a shot, and we'll come back and talk about it. Okay, so hopefully you worked through that problem a little bit, so let's go through it together. So we want 2 values on the unit circle. That's 7 pi over 12. And again, I told you my hint was you're going to add 2 of these. The most obvious ones, we notice that this is 7 pi over 12. And of course, that's a little over half. 7 over 12 is a little over half. So what we're going to want to do is add pi over 3. Let's try adding pi over 3 and pi over 4 and see what happens. Okay, so again, we need a common denominator to add those two. We need a 12 and a 12. So again, I have to multiply this 3 by 4 to get to 12, so I'm going to do that in the top. And I multiply 4 by 3, so we're going to put 3 pi in the top. And we see that that indeed does add together to 7 pi over 12. So that means that we're going to want to break this down into the 2. We're going to say cosine of, and again, use the ones that they originally were, not the ones you changed them into, because we know that they will become this, but we want to break it down into the 2 special right angles. So we get cosine of pi over 3 plus pi over 4 should give us 7 pi over 12. Okay, let's use our sum and difference identities that we see on the first page. So cosine of something plus something is going to be cosine, cosine minus sine, sine. So we're going to say cosine of pi over 3 times cosine of pi over 4 minus, so remember cosine differs in that if you have a cosine it's going to be different from the sine, sine of pi over 3 times sine of pi over 4, like that. Okay, so again, we just go in our unit circle and we look and see where those match. So cosine of pi over 3, let's see, that's going to be 1/2. Cosine of pi over 4, that's just the square root of 2 over 2, minus sine of pi over 3, that's going to be the square root of 3 over 2, and sine of pi over 4, that's the square root of 2 over 2. Cool. Alright, so we just do a little bit of math. Again, common denominator of 4. You'll notice that recurring theme there. 1 times the square root of 2 is just the square root of 2. And then square root of 3 times the square root of 2 is the square root of 6 with a negative in the middle. And that is our answer. So there we go. So again, we've seen these cases where the sum and difference identities can help us to evaluate functions that aren't values that we are familiar with on the unit circle. So that's good because now we have these values for 7 pi over 12, which again is not on the unit circle. But sum and difference identities can also be used to help us verify identity, right? So let's actually look at one of those. So here we want to verify that sine of theta plus 3 pi over 2 is equal to negative cosine of theta. So how do I do that? Well, again, we notice we have a sum inside of sine, so we can use our sum and difference identities. So we say, okay, well, the sine of alpha plus beta is sine cosine plus cosine sine. So let's just break this down into that. So we're going to say sine, let's break it down. So that's going to be sine of theta times cosine of 3 pi over 2 plus cosine of theta times sine of 3 pi over 2. Okay, so what's going to happen here? Well, we can't really do anything with these because they just have a theta. We don't really have anything for that. But again, cosine of 3 pi over 2 and sine of 3 pi over 2 are on the unit circle. So cosine, we go to 3 pi over 2, cosine is the x-coordinate. We see that that's a 0. So this whole term right here is actually just going to equate to 0, right? So it just goes away. So we're only dealing with this thing on the right side here. And so what we notice is at 3 pi over 2, that y is actually -1. So we're going to say cosine of theta times -1, because that sine of 3 pi over 2 becomes -1. And -1 times cosine theta is, of course, negative cosine of theta. And is that what we wanted to confirm? Yes, it was. We have verified that identity. So let's go ahead and do number 7 together. So what we're going to say here is, okay, well, cosine 360 minus theta is equal to cosine of theta. So let's break this down. So cosine with a minus in the middle is going to be cosine, cosine plus sine, sine. So we're going to say cosine of 360 times cosine of theta plus, again, remember with cosine, the sign differs from what you put on the right, sine of 360 times sine of theta. Okay, so what is cosine of 360 and sine of 360? Well, we go up here, and again, remember that 360 is the same coordinates as 0, right? So it's the same as going all the way around the unit circle once. So the same coordinates we use for 0, we're going to use for 360, which is 1, 0. So cosine is the x, which is 1. So this just becomes 1. So we just have cosine. Plus, well, 360 at there, the y is 0, which is sine. So that actually will just go to 0, so we don't have to worry about that. And then we just get cosine, which is what we wanted to verify, which is nice. All right, so now what I'm going to do is let you do number 8 by yourself. So go ahead and pause the video, give that a shot, and see what you get, and we'll come back and talk about it. Okay, so I'm assuming you went through this, looked at it, tried to work through it, and so now let's go through it together. So again, sine pi over 2 plus x is equal to cosine. Let's try to verify this. So sine plus is going to be sine cosine cosine sine. So we say sine of pi over 2 times cosine of x plus cosine of pi over 2, and then sine of x. And you probably figured out the theme. One of these is probably going to go to 0. And so we look at pi over 2. The x-coordinate, or the cosine at pi over 2, is indeed 0, so this will just go away, because this is equal to 0. Sine of pi over 2 is 1, so that's just going to be 1. And so that's just going to give us cosine of x, which indeed is what we wanted to verify. Okay, so that looks like it is it for the lessons today. Again, if you have any questions, please make sure that you raise your hand and let me know so I can come by and help you out. And actually what we're going to do today is we're not going to take these notes for a grade. What I want you to do is on the next page, you have this exit ticket, and what I'd like you to do is work through these 2 problems and then give it to me, and that will be your daily grade. Now again, I'm not going to grade you based on whether or not you get these correct or if you understand. I just want to see where exactly you are in understanding this material. So try to work these out too. Go ahead and hand them to me. Please, again, place your name at the top so that I know who you are, and your period as well. And be sure you give this to me as your notes, and instead of your notes, and then I can check it and make sure that you've done it correctly, or I can come by and help you so that you can get this. Okay, so that is it. Hope you guys enjoyed that video, and I'll see you next time.